In this video, I want to show you how to solve a quadratic inequality and some special considerations that you have to keep in mind. Now, there's basically two techniques I'll cover. One is graphically, so if you know a lot about the graph, you can kind of figure out what's going on. And the second is algebraically, so you won't be able to see the graph of it, but still be able to come up with the appropriate solution. Before getting into the solving process too much, remember that with inequalities, we're looking for entire ranges of values that x can be. So these will not be isolated points, but instead a whole range of x's that could satisfy the inequality. Now, for this first one, x squared minus 3x minus 4 is greater than 0, we could do it completely graphically. Now, what I mean by that is you could take the expression on the left side and graph it out, and then try and figure out where is that graph either above 0 or below 0. So I've already gone through the process of graphing it, and I have it here on my little graph. You can see that, for some parts of this graph, it's definitely above the x-axis, above 0, and some parts it's below. If it helps out, I can even color code it like this. So when is the graph in the blue, and when is the graph in the red? Well, according to the inequality, we're interested in places where it is greater than 0, so we're in the blue. Well, this will happen when you use x values between negative infinity up to negative 1, and from values from 4 up to infinity. So notice how it includes both those ranges of values. Now, with the values in between negative 1 and 4, it does not include that range because during that section of the graph, it is below the x-axis. Now, since we've covered lots of different techniques for graphing quadratic equations, this is a good visual way to represent what you're looking for, whether it's above or below 0. The second approach to, say, solving one of these inequalities with a quadratic is to take a more algebraic approach. What you do is you first set the inequality with 0 on one side. And the reason for this is so you only have to worry about positive or negative values. So, get it equal to 0. Then you want to know when it will equal 0 exactly. And to do this, you may have to go through a few special techniques. You might have to factor it, or you may even have to use the quadratic formula, just as long as you know where it is equal to 0. Now that's important because at those points, that's where the sign could change. Then you want to divide your x-axis into different intervals depending on what values gave you the zeros. You'll select test points from around these values to see whether it is positive or negative. And then depending on what the inequality says, you'll either take the positive values or the negative ones as your intervals. Now, it's also good to note that some of these inequalities will be strictly greater than or strictly less than, or they may have greater than or equal to, or less than or equal to. If it has the or equals to condition in there, then sometimes you may be able to include the endpoints. If it's strict, then you definitely do not want to include those endpoints. So just something to keep in mind as you're going through that solving process. So I'm going to use the same quadratic inequality and show you how we can arrive at the same solution. Now, if I follow through the steps, one of the first things I want to do is make sure that 0 is on one side of my unequal sign. Well, this one's already set up that way, so I'm pretty good. In the next step, I want to see what places will actually equal 0. So in other words, set it equal to 0, and use one of your special techniques to see what x can be. Well, this one actually factors really nice, and so I know that x will equal, or the equation will equal 0 when x equals negative 1 and when x equals 4. Now, what I'm going to do with each of those points is use them to divide up my number line. And notice when I put those points on there that I basically have three different sections. I have a section with values that are less than negative 1. I have another section for values between negative 1 and 4, and then I have a third section for all values greater than 4. So my solution for what ranges of values will work will come from some of these intervals here. I just need to check to see which ones are going to work. To see exactly which intervals are going to work, I'm first going to basically just list out those intervals. So I can see the values less than negative 1, between negative 1 and 4, and from 4 greater. And from each of these individual intervals, I'm going to choose a point. This will be known as my test points. And you can see that, like the negative 2 came from that first interval. 0 came from the middle interval, and 5 is in the last interval. we're going to take each of these test points and plug them into the function to see whether it's positive or negative. So if you plug in a -2, it looks like you get a 6. Now, the value is not quite as important as the sign. You get a positive 6, so we'll make a note. Now, if you plug in a 0, it looks like you get a -4. And again, we're not too much worried about the value, but we are definitely concerned about the sign, a negative. And lastly, you could plug in a 5 and get another positive 6. So we'll note that, a positive. Now, since we're interested in places where it is positive greater than 0, we can see that our solution comes from the first interval and the last interval. So the -infinity to -1 and the 4 to infinity, those two intervals become our solution. Now, another way that you could break this down and get a better idea as to which intervals to take is to look at the individual pieces present in the quadratic inequality. So what I've done is I've taken the places where it is actually equal to 0 and I've put those on a number line. And I've taken all of the factors of the quadratic as well, so x minus 4 and x plus 1. And you can test out those individual pieces on the number line. So imagine using those same test points, but use them in just the individual pieces. So what happens when you plug in a -2 into x minus 4? Do you get a positive value or a negative value? Well, you should get a negative. What happens if you take 0 and plug it into x minus 4? What kind of value do you get then? Well, sure enough, it still tends to be negative. And when you choose something larger than 4, say a 6, and plug it in, then you'll actually get a positive value just for that little piece. You can imagine doing the same process using those test points into the quantity x plus 1. Now, since those two pieces of the quadratic are being multiplied together, in the first interval you basically have a negative times a negative, which will give you a positive. In the middle interval you'll get a negative times a positive, so that will be negative. And in the last interval you'll have two positive quantities multiplied together, so a positive. So another way to see that it's definitely positive on the first interval, negative in the middle interval, and positive on the last interval. And since we're only interested in intervals where it is greater than 0, because that's what the inequality says, greater than 0, then we will only take the positive guys, and so this is our solution intervals. Now keep in mind that the inequality present is a very strict inequality. It says strictly greater than, so we will not include the endpoints. Now if it did said greater than or equal to, then we'd actually use a square bracket on the -1 and on the 4, just to show that those are included. But definitely watch those as you're working through the problems.